Alright folks, so for these videos what I'm going to be doing is I'm going to be going through and I'm going to be doing some of the optional exercises just to show how UI, UE, EI, and EI, EE, and EI actually get used for our proofs. So let's start with translations and with some proofs. So let's go ahead and write down our key. And I already have it set up here just because I didn't want to have to write all of this out by hand. So let M be spot. Let dx be x is a Dalmatian. And let bx be x is beautiful. So then for our premises, we have the following. We have spot as a Dalmatian. DS, this is an assumption. All Dalmatians are beautiful. For all of x, if x is a Dalmatian, if x is a Dalmatian, then x is beautiful. So our goal is to show that spot is beautiful. So in line 3, from assumption 2, we want to make this into ds arrow bs from 2 ue. Since it's ue that we're using, we're allowed to replace that x with any variable that we want. Since we already have ds, namely the s, and our goal is bs, we know that we're going to want to use an s. Then in line 4, we can say that from line 1 and line 3, it follows that spot is beautiful. 1, 3, MPP. And that's all that you would have to do for this type of problem. Let's keep going. So again, we have spot is beautiful. Let M be spot. Let dx be x is a Dalmatian. Let bx be x is beautiful. Now our premises, however, are a little bit different than what we had the first time. We again have spot, but this time we're talking about spot being beautiful. And then we have no Dalmatian is beautiful. There's two different ways to write this. We could write for all of x, if x is a Dalmatian, then they're not beautiful. Or we could write for all of x, if x is beautiful, then they're not a Dalmatian. That's just contraposition. I'm going to choose this one because it's easier and doesn't require me to do a modus tollens, or rather, it doesn't require me to do a double negation. But I'll do the other one as well. Then no Dalmatian is beautiful. For all of x, if x is beautiful, then it's not a Dalmatian. Both of these are assumptions. Line 3. From line 2, we use UE. And then for line 4, using 1 and 3, we get not ds, using MPP. And then for our assumption lines, that's a 1, that's a 2, that's a 2, and that's a 1 and a 2. Now, let's say that we had a different premise here. Let's say that premise 2 was actually for all of x. If x is a Dalmatian, then they're not beautiful. All you have to do is, for 3, we would still do our s replacement. But for line 4, we would have to double negate the bs first on line 1. Why? Well, what we're trying to do is we're trying to do a modus tollens. That means we need the negation of the entire right side of that arrow, what I've underlined in right. BS is not the negation of negation BS. It's the opposite, but as we've learned in this class, opposite is not the same as the negation of. And then in line 5, we would be able to say not DS, in this case from lines 3, 4, MTT. Then that would still be a 2, that would be a 2, that'd be a 1, and then it's a 1 and 2. So one of these is slightly shorter and slightly faster, but both of them would work. Just don't forget that double negation if you do it this way. Okay, let's go on to the next page. All male nurses are sympathetic. William is not sympathetic. William is male, therefore William is not a nurse. Well, let's go ahead and start with our key. Let's let N be William. Let Sx be X is sympathetic. Let Nx be X is a nurse. And let Mx be X is male. We have three premises here. So we have all nurses are sympathetic for all of X. If X is male and a nurse, then they're sympathetic. You're allowed to have something that's and ampersanded together with a universal claim, but notice that the main operator is still an arrow. On the homework, a number of people were still trying to put ands for universal claims, and don't do that. You'll just get it wrong, and I can't give you really partial credit anymore for that because we've been over it. So don't do it. We have William is not sympathetic, so not the case that sympathetic is William. It's an assumption. William is male. That's an assumption. So our goal is to say that William is not a nurse. Not in W. Now, there's going to be a couple of ways that we could do this. I'm going to show you the short way because, well, learning to do these in the fastest way possible is helpful on your exams. So let's get started. So first things first, for line 4, we want to get rid of that universal X. One of the things that I saw a lot of folks trying to do in class is they would just start with this. And then they go ahead and start trying to do like MPP or MTT on that with that universal still there. You cannot do that. You have to get rid of any of the quantifiers first if what you're trying to do involves something bound by the quantifiers. If you try to do that in the exam, you probably won't even get partial credit, to be honest, because that's just really, really bad and not in following anything the book has said or I have said. That said, if you have something that looks like this, notice that the main operator is here. It's not bound by any type of quantifier. It's connecting two individual quantifiers. This is the only case where you don't have to touch any of those quantifiers first, and in fact, you can't. I'm going to come back to that in a later video, but please do be mindful and intentional when you're trying to solve these problems. There's a way to do it, and there's lots of ways to not do it. Now, back on task. So from line 1, we are going to want to translate this into MW and NW, arrow SW. 1 UE. Line 5, well, we have a Modus Tollens situation going on here. So not MW and NW follows from lines 2, 4, MTT. Now there's a few things that you could do here. You could do a De Morgan's, then double negate 3, then do a destructive syllogism, or you could look at your sequence sheet and look down at the 34s. There is a rule that says if you have the affirmation of a piece of a negated ampersand, a negated and statement, you get the negation of the other piece of the ampersand. In other words, we can go ahead and get to negation in W from lines 3, lines 5, with, what is it, SI, which piece is going to be? This is going to be SI 34.1, also known as conjunctive syllogism, also known as MPT. Now for our assumption numbers. 1, 2, and 3, that's a 1. That's a 1 and a 2. That's a 1, a 2, and a 3. So it gets all of them, and that's how to solve this proof. All Frenchmen except Parisians are kindly. Jacques is not Frenchman. Jacques is not kindly. Therefore, Jacques is a Parisian. Let's start with our key. Let's let this be Jacques. X is French. I guess I could say Frenchman. X is kindly. X is Parisian. Alright. So our goal is to say that Jacques is a Parisian. In other words, P in. But let's start with our premises. All Frenchmen except Parisians are kindly. We can translate this for all of X. If S is a Frenchman and not Parisian, then they must be kindly. 2. Jacques is a Frenchman. 3. Jacques is not kindly. 4. So the first thing that we're going to want to do here is get rid of that universal that's binding in premise 1. So we know that we want n, so we're going to change this to fn and not pn, gives us kn, 1 ue. For 5, we have a modus tollens situation going on here, so we're going to do not fn and not pn from 3, 4, mtt. Then I'm going to go back to my secret introduction sheet and see that I have another 34.1 going on here. And that's going to allow me to say that it's not the case that I don't have Jacques being a Parisian. Why? Because 34.1 says if I have P and I have not P and Q, then I'm able to say not Q. But notice what I have is I have a negated Q. Since I already have a negated Q, it means I have not Q. This is a substitution instance of the SI rule. It's a valid inference. This is one of the exam questions that folks got wrong on the last exam, actually. Happens, but do know it. So from 2 and 5, using SI 34.1, we can get not PN, and then we can get rid of those double negations using double negation to just get that Jacques is a Parisian. 6 DN. Then we add in the assumption numbers, 1, 2, and 3, 1, 1, and 3, 1, 2, and 3, 1, 2, and 3. And we're done. I think this was the last one. Yep. So this is all that I have for this video. Do practice these. Do go through them. One of your homework problems is C from this section, and this is a model of how to approach that problem.